one of the reputed institution and I have around 25 years experience. Today we are going to know about Doppler effect application. Okay, so it is one of the main part of competitive exams. In every competitive exam you will be given one question. Okay, so today we are going to know about applications of Doppler effect. Okay. So usually in the competitive exams related to this Doppler effect, you will be given three model problems. What is Doppler effect? You know, the apparent change in the frequency of sound received by observer is called Doppler effect. Okay, that is it is a common experience to all. You see, when you are standing on railway platform, when train approaching towards us, we receive more frequency of sound. But same train, when it is moving away from us, we receive less frequency of sound. Okay? So, in Doppler effect, you need to know mainly source, observer. Source means one which produces sound. Observer means one who receives sound. Okay? Apparent frequency received by observer is, n dash is equal to V minus V naught by V minus Vs into n. Okay? So based on this formula only, we'll solve almost all problems. So here V means velocity of sound, okay, in air. Because sound waves are mechanical waves, they require medium now. So the speed with which the sound is moving in air is V. So usually that value will be taken around 340 at room temperature. So that value will be given in the problem. So if you have not given, you can take 340 also. Okay. Next about V naught. V naught is velocity of observer. Okay. And Vs, velocity of source. Okay. And N is original, true. Okay, true frequency. N is original or true frequency. So if you know this, it is easy to solve any problem. And remember one more hint also while solving problems. Whenever source is moving towards observer, you take positive. Okay, observer moving towards source, you take negative. Okay, source towards observer you take positive, observer towards source you take negative. Okay, so if you know this and this formula, it is easy to solve any problem. Okay. So now first one about horizontal platform. So here let us consider two sources, okay, two cars which are moving on the horizontal surface in opposite direction, like this, approach each other, or they may go away from one another. So let us suppose this car has given horn, okay, moving in one direction, the other car is coming in opposite direction. So this is observer, this is source. Okay, like this. So one core is source and the other core is observer. So whenever source is towards observer, I said positive. Observer towards source, negative. Now put in the formula V minus of minus V naught by V minus of plus Vs into N. So you can write V plus V naught by V minus Vs into N. So what do you notice? Numerator is V plus V naught, whereas denominator, V minus Vs. So numerator is having more value than denominator. Obviously, result will be more, no? So we can say N dash increases. And remember, if observer is at rest, say a traffic police standing, no? So observer is at rest. Then whenever source is moving towards the observer, corresponding velocity of the observer will be taken 0. Okay? So if observer is at rest, take V naught 0. Or if source is at rest, take Vs 0. V velocity of sound in air. Okay? Like this you can solve any problem. So here I have taken approaching each other. So you may take one away from other also. Say source, observer. Then Vs will be taken negative and observer will be taken positive and substituted in the formula. So you get minus and plus. So what do you notice? Here numerator is having less value than denominator. So instead of increasing, you get decreasing. That is when they are going away from one another, like this. This is source, this is observer, are moving away. Okay. So it is one model. Okay. Now next one about circular path. Say there is one source moving in circular path like this. Okay, and observer standing at a point. Okay, source is moving in a circular path and observer is standing. Source in a circular path, observer standing. So there are three possibilities to observer. At one point he may receive more frequency, at another point same frequency, next less frequency. So I have chosen 3 points, source at A, B and C. Source is moving in a circular path. So its linear velocity taken as R omega. So R is radius of this path, omega 2 pi n. N means number of rotations made per second. Okay. So whenever source is approaching towards observer, velocity will be taken positive. Away, negative. So the formula which we are using, n dash is equal to V minus V naught by V minus Vs into n. Now, so V, velocity of sound in air, V naught, velocity of observer, and n is actual frequency. Over here, observer is not moving, so corresponding velocity taken 0 now, and n dash is equal to V by V minus of plus, instead of Vs you take R omega now into n. So what do you notice? In this case also, denominator is having less value than numerator. Obviously frequency more means increases. Okay, so source approaching towards the observer, frequency increases. Now suppose you are taking this case, that is when source is going away like this. It's going away from the observer. So when it's going away from the observer, this Vs will be taken negative now. So in place of this plus, you will write minus. Okay, so thereby you know this minus of minus will become plus now. So you get n dash is equal to, okay, v by v plus r omega into n. That means in this case frequency will be less because observer is going away. Okay, so this is one model. I can interchange also. Say observer may be on circular path, source may be standing, okay, at some point. Okay, or in some other cases, so observer also may be in a circular path, say in a cradle or in a swing. Okay, so you know when moving towards the circular path more, away less. No, so if observer is in the circular path, take V naught as R omega. Say source is in the circular path, take Vs as R omega. Okay, now about the other one, inclined plane. See this one, inclined plane. Source is on inclined plane and observer standing. Okay, so source is on inclined plane, observer standing. So whenever source is on inclined plane, okay, this is the resultant velocity, say V, no, and it is horizontal. Vertical is upwards, no. So when you consider it, the source on inclined plane, only the horizontal component is only contributed to the observer. So this is inclined plane, source moving, okay, observer standing. So you know this is the resultant velocity of source. You can resolve into two components now, horizontal, vertical. Okay, so to observer only horizontal component is contributed. Okay, so in this case also I am taking 3 points, A, B, C. The point where source approaching closer to observer, perpendicular to observer, away from observer. Okay. So this is the formula. Again we are using the same formula. There is no change in the formula. I am using only one formula. Okay. V minus V naught by V minus Vs into N, because you see usually when you are going to write a competitive exam, it is very difficult to remember too many formulas, right? Instead of that, if you remember only this formula, no, it's easy to solve any problem. Okay, or here source is on inclined plane and observer standing. As you know, as observer is standing at some point, its corresponding velocity will be taken 0, right? And you know, V velocity of sounding, usually that value will be given. If it is not given, you can take 340 also. And you know, n is original frequency, the given frequency of source. Okay. Now about Vs. So you know, in this case, as observer is standing, source is towards observer. So you know, Vs will be taken positive now. Into n. So plus into minus is minus, right? So you get V by V minus Vs cos theta into n. Okay? So in this case also you know, numerator is having more value than denominator. So obviously the result will be more, you know. So frequency towards observer increases. Say the source is going away from the observer. Okay, then you know whenever source is away now, so instead of plus you take minus, right? So this will be minus. Then minus of minus plus. That is all when source is going away from the observer. And you know over here, source and observer are at right angles. No? So that is why no change in the frequency. Okay, when source at point B, observer will receive true frequency only. Means whatever the source gives, observer will take only that. No change in the frequency. But when it approaches towards him, he will receive more. Away, less. Okay, so like this you can solve too many problems easily without any confusion. So here you need to remember only 2 points. One, main formula, V minus V naught by V minus Vs into N. Okay, and V naught observer velocity, Vs source velocity, and true frequency. Okay, source towards positive. Okay, observer towards source negative. Opposite is opposite. Okay, so I am going to solve the problems in the next part also. Okay, if you like this video, please like, share, and to many students so that I can produce you more and more videos. Okay, thank you for watching this video.